Okay, welcome to Planet Geography. Today we're dealing with storm hydrographs. Storm hydrographs have quite a large amount of key terms, so I'm going to flash these up, pause the video, have a quick read about what they are. What we'll do now is we'll work our way through these key terms and break down a storm hydrograph through that. So this is a line graph, so we know time is always going to be at the bottom. It's going to tell us a story. On the x-axis, on the y-axis, we have rainfall in millimeters, and that's displayed in a bar, so just like a climate graph. But we also, confusingly, have another set of information on our y-axis, and that is discharge, the volume of the river. It's measured in cubic meters per second. Essentially, it's measuring how many cubic meters of water pass through in 1 second. Okay? So, let's go through the key terms. Peak rainfall, the highest amount of rainfall. So this is when the level of precipitation is at its most intense. You can see before and after, it's less intense. We also have peak discharge, the highest river level after the storm. So this is when the river is at its most full. If it does flood, this is when the flood is at its most severe. So peak just means top. So peak rainfall and peak discharge. Lag time is the difference between the two. Almost a tiny percentage of water will fall directly into the river. The rest falls on land throughout the drainage basin. And that will take time to travel to our river. Okay? So lag time is simply the difference in time between peak rainfall and peak discharge. And if you go down and you look at peak discharge, it's not even raining when the flood is at its most intense. Okay? And that is because of the lag time. Rising limb and falling limb are quite easy. Rising limb means just discharge is increasing, the river's getting fuller and fuller and fuller. And falling limb is when the river is subsiding, its volume is decreasing, essentially it's not as full. We have base flow, which is the normal average of the river, and eventually the river will return to its base flow. We also have anything above the base flow is considered storm flow. So what I'm going to add to this is we're also going to have bank full discharge. Now, bank full discharge is when the river is in flood. So what does that mean? Well, rivers have channels and they can hold a certain amount of water. So here is our river's channel. Here are our banks. And rivers can hold a certain amount. When it reaches bank full, the river can hold no more water and it has no other option but to flood. Okay? And that's what bank full is. So, guys, storm hydrographs, kids tend to find them quite tricky. But if you know your key terms, you understand what lag time is, this is really what kids struggle with, lag time, then you should be fine. What we'll do now is we'll jump into an exam question and we'll break down how these appear regularly in exams, because they really do appear regularly, and how examiners tend to create questions for them. Okay? So, I'll see you there. The question from 2019 Geography A. So, this is what you would have had in the exam. Here is the figure you need to look at. Storm hydrograph of an urban catchment area A and forest catchment area B. So basically what they've done is they've given you the storm hydrograph that we've looked at, but they've added two different rivers onto it and applied it to the same storm. The question that you'll get is examine how land use affected the storm hydrograph for A and B. Now we haven't looked in this video at the kind of urban versus rural causes for storms. We just looked at how you actually use this. So if you were to use this, you've got to be talking about the urban, which is with the X, very steep rising limb, very short lag time. You're going to be saying that the river B, the forested river, has got a much flatter rising limb and a much longer lag time. So these are things you could say. Again, these are things that we didn't cover in the video because it wasn't the content that we were looking at. But here, this is what the things that you would be kind of saying. River A, lag time 3 hours. River B, lag time 6 hours. So could you do that? River A, 268 cubics, B, 70. So what you're saying is here, you'd be adding your points about maybe kind of urban areas, use gutters and drains, less interception from trees, deforestation, blah, blah, blah. But then what we've learned today is how would you actually use this, okay? It's an 8 marker, so you'd be expecting to do quite a lot. And here, this is where you get your AO4, by being able to interact with the resource, okay? That is what a question often looks like in a GCSE exam question. And so you need to be able to break down it if you are to get those marks. I hope that helps. Like and subscribe for future videos. And good luck in your GCSEs.